Welcome to a new session. Today we will briefly explain graph. So um, a graph is a non-linear data structure used to model a relationship between objects, or in another word, a graph is a collection of nodes connected by edges. I think this definition is more comprehensive than this one. Here you see this picture. It is a collection of nodes connected by edges. So it is a graph. Like in our previous lessons, we studied the trees. Tree is also a kind of graph. Like you saw, it was a collection of nodes connected with one another by edges. So when you start studying the graph, there are some key in, details or key informational or key points that you should know in order to be able to work with the graph. The first one is graph representation. You should be able to represent a graph in programming. Like here we see here's a picture, but when you want to work with this graph, you should be able to represent this picture in your programming, in your coding. So you should know this knowledge. And there are two major approaches. One is the adjacency list, the other one is the adjacency matrix. In adjacency list, you represent this graph in a key value pair data. So you make a list of key value pairs, and all the nodes are acting as the key, and the value to those keys are all other nodes which are directly connected to that node. For example, node number 1, it is directly connected to node number 2 and node number 5. So if it is the key, the value of an array of these two neighbors directly connected to this one. And with the rest, for example, let's check number 2. So it is directly connected with 1, 5, and 3. Let's check node 2, 1, 3, 5, 1, 3, 5. So it is how you represent a graph using a list in a key value pairs. And another approach is the adjacency matrix. Adjacency matrix, it is a two-dimensional array that you write your nodes in row and columns, and then you match them. If they have directly connection to one another, you put them 1 or true, or sometimes the weight of the edges. For example, sometimes you see these edges have a weight that shows the distance, the price, the cost, or whatever the graph represents. For example, if the graph represents gas stations, it may show either distance or distance, for example. Or for example, if there's two bus stations, it may show the price of ticket, for example, from here to there, it is this much. So these edges show some values, and you study that under the weighted graph. So if they have a weight, instead of writing 1 or true, you write the weight of that edge. For example, let's see node 1, it is directly connected with node 2 and node 5. So let's see node 1, it is directly connected with 2 and 5. So when they intersect one another, so it should have the value of true or 1 and 2. So let's see 1, and here 2. See 1 and 2, it is 1, the rest are 0. And then 1 and 5, 1 and 5, it is 1. Or for example, let's see number 2, it is directly connected with 3, 1, and 5. So the intersection should be 1, the rest should be 0. So 2 and 3. So let's check node 2 and 3. See, node 2 and 3 here, the value is 1. Or node 2 and 1, for example, node 2 and 1. Or node 2 and 5, node 2 and 5. See? So it is how you represent using a matrix. And it is a two-dimensional array. So as soon as you could represent your graph in your programming using a list or a matrix or an array, a two-dimensional array, now whatever operations you need with the graph, it depends all on your knowledge of list or arrays, two-dimensional arrays. Like if you are comfortable working with arrays, you can represent your graph using a two-dimensional array. But if you are comfortable working with a list, then represent your graph using a list. However, you are more comfortable working with them, just use any one of them. So now that you know how to represent your graph, the next key point is that you should know how to traverse your graph. So you should know the graph traversal algorithms. There are so many algorithms to traverse a graph, but two of them are very popular. One of them is the breadth first search, BFS, and the other one is the depth first search, or DFS. So in breadth first search, you start from a given node and explore the graph level by level. For example, if you start from this node, then you process this one, and then you go to the next level. You process this two, and then you go to the next level. You process this two, and then like level by level. But when it comes to depth first search, you explore as deep as possible before backtracking. For example, if you start from this node, so you start going as deep as possible, either from left or right, doesn't matter. So you go like, if you take this way, you go to 1, 5, 4, 6, then you start backtracking to 3 and 2. Or if you start from here, 1, 2, 3, 4, 6, 5, and then you visit all the nodes in the graph. Or let me show you how that works. For example, let's see. Okay, so when you use BFS, you use Q in order to keep track of visiting all the nodes. So you need a queue. Okay, you need a queue in order to like check every node. You add every node here in the queue, and then you start processing them. So, and let's start from number 1. As soon as you give this root node, like it is given as a root, or it is given as a beginning point, so you add that to your queue. Okay, number 1. So now number 1 is in your queue, and as soon as you create your queue, you added your root. Actually, you need one more list just to keep track of visited ones, in order not to check them again and again. Visited nodes. Okay. So you add number 1 here also, because that is the root, the given node. So that means that's already visited. That is already considered as a visited node. Okay. So now, when the root is given number 1, so you put that in the queue, and then as far as the queue is not empty, you keep dequeuing the elements from your queue and process that. By process, I mean you check its value, because you might be looking for some specific nodes in your graph. So you remove it from the queue and you check that. For example, so now you see that there is one node in the queue, and you remove this like this, or let me just delete that like this. So you remove that from the queue, and as soon as you remove this, so you take that and you process that. By process, I mean you check its value, and then when you are done checking its value, you take its neighbors to the queue. So for example, it was given as number 1 was given, so you process number 1, and now you add its neighbors. So you see the neighbor is an array, so you make the queue, which is number 2 and number 5. I don't know how this series started working here. Okay, so 2 and 5. You added 2 and 5 to the queue. And now, you know that queue is first in, first out. So first I entered number 2, and now when I added all the neighbors of this number 1, I take the first node from the queue and remove that, and then process that. And when I'm done processing that, then I add that neighbor to the queue. So I process number 2, and I take number 2 now, process the neighbors of number 2. So it is 1, 3, 5. And also when I process number 2 here, so I add that here, because that means I process that and I visited that number 2 is visited. So I should not visit that again. So now come to the neighbors of number 2. It is 1, 3, 5. It is 1, 3, 5. So if there is a node which is already visited, you don't add that again here. So number 1 is not needed here because that's already visited. Number 5 is not visited yet, but you can add that in the queue, no problem. So this time, when you added all the neighbors of number 2, so the next time you remove one element from the queue, which is number 5, and then you process number 5 and add number 5 to the visited list. So when you add this, and as soon as you visited this, then you add its neighbors to the queue. 1, 2, 4. So 1 is already visited, you don't need to add that. 2 is also visited, you don't need to add that. So you add only number 4. See, it is how you keep avoiding visited nodes again and again. So now you remove number 3 from the queue and you process that. By process, I mean you check that. And when you are done checking that, so you add that in your visited node. And now you add its neighbors to the queue. So you come to number 3, its neighbors are 2 and 4. You add them if they are not visited. For example, 2 is already visited, so you don't need to add that again here. Number 4, but number 4 is not visited, so you add that. Number 4. And when you add all the neighbor, so you remove another node from the queue. Number 5. So that's already in the visited node, you do not process that. You go to the next one, number 4. So number 4 is not in the visited yet. So you take that and you process that. And when you are done processing that, then you add that in the visited list. And now you add the neighbors of number 4. Number 4 has 3, 5, 6. So that is. So do you need to add 3? No, because that's already visited. Do we need to add 5? No, that's already visited. How about 6? Yeah, it is not visited, so we add that to the queue. So now you remove number 4. Actually, I think I made a mistake. We didn't need to add number 4 also, because that was already. Oh, no, we just visited the time, right? So you remove number 4, you process that, and that's already visited. So now the next one is number 6. Yeah, now I think number 4 was added duplicate. So number 6 is the last in the queue. So you remove this one, you process that, and you add in your visited node, number 6. And now you check the neighbor of number 6, which is number 4. So you see that number 4 is already visited, so you don't need to add in the queue. Now the queue is empty. As soon as the queue is empty, that means you have visited every node in the graph. And you see it is from number 1, 2, 3, 4, 5, 6. 1, 2, 5, 3, 4, 6. See, we went level by level. For example, we started from number 1. The next one was 2 and 5. 2 and 5. The next one was 3 and 4. 3 and 4. And the next one was 6. It is how we visit using breadth first search. And now let's see how we can do that using a depth first search. So let me have let me create a stack, because when we use depth first search we need to have a stack. Okay, so I use this as visited one. Okay, okay, so here is our stack. Let's say again we start from number 1. So as soon as the root node is given to us, we add that to the stack. That is number 1. So we added number 1 to the stack. Okay, so now also, as far as we have some element in the stack, we keep checking the nodes. And we said in the depth first search, we have to go from one root as as deep as possible. For example, if you take this child, so you come here as deep as the last one, then you start backtracking. So, and now let's see how we can do that using a stack. Okay, so use a stack, explore as deep as possible before backtracking. So we start from number 1, and as soon as you start that from number 1, so you put that in the stack, and now you check, you keep checking your stack, and you check if there is any element in the stack or not. Right now there is 1, and you know that the stack is the last in, first out. So right now there is only 1, so we only remove that one. We remove that from the stack and we process that. By process that I mean we check its value. When we are done checking its value, we check if it is not already added to the visited list, we add here to the visited list. Otherwise we don't need to duplicately add that to the visited list. So right now number 1 is removed from the stack. We process that, we visited that, and we keep that in the visited list. Now we need to add its neighbors to the stack. So then its neighbors are 2 and 5. So we have to add, let me add first number 2 and then number 5. So that means that comes at the top, number 5, something like this. Because when you add 2 first, so 2 goes down and then number 5. So now there are 2 nodes, 2 values in your stack, and you keep processing until the stack becomes empty. So you remove another node from the stack, and of course that should be the top one. So you remove number 5. Okay, you remove number 5, you process that, and then if it is not added to the visited list, you add that to the visited list. Okay, add number 5 to the visited list, and when you add this to the visited list, so you add its neighbors to the stack. So the neighbor of number 5 is 4 and 2. Okay, 4 first, it is for example number 5, here is number 5, it is 1 2 4. So 1 is already visited, you don't need to add that. Number 2 is not visited yet, so you add that. Number 4 is also not visited yet, so you add that also, number 4, something like this. So, and now the next time you remove number 4 from the stack, number 4 is removed. number 4 is processed, and number 4 is added to the visited list. And now you add the neighbor of number 4 to the queue, to the stack. So it is 3, it is 3, it is 5, but 5 is already visited, you don't need to add that. And 4, 3, 5, and 6. You don't need to add 5, but you need to add 6, because 5 is already visited, but 6 is not visited yet. Okay. So the next term that you need to remove is number 6. You remove number 6 from the stack, and you remove that, you process that, and then add this to the visited list, number 6. And then add its neighbors to the stack. So what is the neighbor of number 6? It is number 4. But number 4 is already visited, so you don't add that to the stack. Then you take the next one from the stack, number 3. You remove that from the stack, and you process that, and then you add that to the visited list, number 3. So when you add this to the visited list, now you need to add its neighbors to the stack. It is 2 and 4. So you can see 2, but 4 is already visited, so you don't need to add 4 to the stack. Okay, and then you remove the next node from the stack, which is number 2, and process that, and then you add this to the visited list. So when you add this to the visited list, and now you check its neighbors, it is 1, 3, 5. 1 is already visited, you don't add to the stack. 3 is already visited, you don't add to the stack. And 5 is also visited, so you don't need to add to the stack. Then you remove the next node, 2, it is already processed, and 2. And now the stack becomes empty. When the stack becomes empty, that means you have visited all the nodes. And now see, you started from number 1, then you check number 5, then you check number 4, then you check number 6. See, you went checking them as deep as possible. When you use a stack, it happens. And then from here you start backtracking. Then when you went like this, and then you start backtracking, you check number 3, and finally you check number 2. So it is how BFS and DFS works. Using a DFS, you use the stack. Using a BFS, you use queue. And in the next session, I will write actual codes how to use DFS or BFS with adjacency list or adjacency matrix. Until then, have a nice time.